So the question we have here says, given that the Ksp of radium sulphate, Na2SO4, the choices of it, is 4 times 10 raised to the power minus 11. Calculate its solubility in 0.10 concentration of Na2SO4, sodium sulphate. So let's first of all analyze the question. They gave me RaSO4, and this solubility product of radium sulphate, the Ksp, they say that is 4 times 10 raised to the power minus 11. Then they now ask me to calculate the solubility of radium sulphate in, I should calculate the solubility, that's what the question is saying. Calculate its solubility in 0.1 mole, that is 0.1 concentration of solubility of RaSO4 in 0.10 m. I always take this to mean concentration, or you say molarity, but in this case they normally take it to mean mole of Na2SO4. So this is not really about me finding the solubility of radium sulphate, but rather its solubility inside Na2SO4. So let's get to work. So what I will do in this case is to simply first of all get a solubility equation and a Ksp equation for radium sulphate. So RaSO4 on the solution will produce a reversible reaction which will give me Ra2 plus and plus SO4 2 minus. That is what it will give me. So that means that if I know this, let's say I call this now, because I don't know the solubility, but I know its Ksp. Ksp of this will simply give me, at this point it will be K equals to this all over this solid, but since it's constant it will multiply this and now give me Ksp to be equals to R. Just know it that solubility product is always equal to what you have here, product of what you have on the right hand side from the solubility equation. So that this is going to be Ra2 plus, this box is concentration box, SO4 2 minus, and we don't start to do anything with the ions, we just put it there, indicate it, finish. Now the Ksp is given to me to be 4 times 10 raised to the power minus 11. So it's equals to Ra2 plus and SO4 2 minus. Now let's say in this case I call this X and I call this X because I don't know it, which means that it will be equals to 4 times 10 raised to the power minus 11. But notice that we are given to find its solubility inside Na2SO4. And if I do this Na2SO4, this is going to be the same thing as saying, let me do it here. Okay, let me just solve it differently. This is going to be Na2SO4 should give me on the solution 2Na plus sodium, then plus SO4 2 minus. That means its Ksp is going to give me equals to, we don't use this for Ksp, so we don't do, so it's going to give me, I know that in some textbook you see this thing as Na plus only, then the 2 you don't have to put it, but you still see that when you are multiplying the value of that 2 you will still put it. So let me always put it in my own so that there will be no confusion. So then SO4 2 minus. So this is what you will have, but remember that we are giving the solubility of this to be 0.1 m. That means this one also has 0.1 m equals to the Ksp. So what this thing means is that if I carry this radium sulphate and come here, notice that, let's say I put radium now here, down here, that it is entering this liquid, it is entering this solvent. If radium enters inside, the Ra2 plus and Na plus will have nothing in common. But the minute I put SO4 2 minus and that of SO4 2 minus, which is 0.1 in this case, you see that these two will add up, they will mix up. So that means if I call this X, if I call this X, if it enter here, it will not mix with this. But if I call this SO4 2 minus, the minute it enter here, it will see another SO4 2 minus, they will mix up fine. So if I call this X, it will now become X plus 0.1 m. So let's now go and say, since we are finding the solubility in sodium sulfate, that means that if it enters sodium sulfate, this remains X, and this one becomes X plus 0.1. So all these will be equals to 4 times 10 raised to the power minus 11. So this is what remember the question, assuming we are asked to find the solubility of radium sulfate, this is what we will find. But this one is inside Na2SO4, the solubility. So this is what I'm going to find. This is what I'm going to work with. So that means that if I get this, we normally take it that we ignore, at this point, we say since SO4 was found inside the SO4, whatever value I find there, that is what I use. Some textbook will tell you ignore it. That is, ignore the X this time around and take this, because whatever X becomes in this case will not be too far from what you got inside there. So I just say since I found SO4, or they tell you since the Ksp is small, it will not make much impact. We did that one in class, but just take it that since I found SO4 2 minus inside the other one, assuming I put radium sulfate inside calcium fluoride, the two will not mix up. So what I will just solve for the solubility is just this thing, they will not mix up. But if I find any ion of a particular solvent or solute inside another solvent, let's say I find the ion of a solute inside another solvent, I just replace it with whatever concentration I have there for that. So that is what you talk, or how you go about when a particular solute, the ion of a solute, is getting furnished by the ion of another, which is the solvent. So I will now have X. Remember that this will come like this. This will come like this, equals to 4 times 10 raised to the power minus 11. So when these two times, it becomes X, 0.1x. It becomes 0.1x equals to 4 times 10 raised to the power minus 11. So X will simply be divided both sides by 0.1. So you see that if you do this, because I know that 1 divided by 10 is 0, this thing is the same thing as saying 4 times 10 raised to the power minus 11 all over 1 times 10 raised to the power minus 1. So equals to X. If I use indices now, you see that this becomes equals to 4 times 10 raised to the power minus 11. When this minus comes up, it becomes minus minus, which is plus 1. So X is equals to 4 times 10 minus 10 all over 1. X is equals to 4 times 10 raised to the power minus 10. And that is the solubility. So we can say that the solubility of radium sulfate of RaSO4 in 0.1 Na2SO4 will be equals to 4 times 10 raised to the power minus 10. And notice, remember that solubility is given by the unit mole per liter. So that will be it. So you will see that for the fact that I have, what's it called? I have the solubility of radium sulfate. Now see, this is 4 times 10 minus 10. mole per liter, which is 0.00000. So you see that it has more negative. It has more negative than this given solubility, which is just 0.1. So you see that the solubility of radium sulphate decreased. So you see that it decreased. So which means that that of once you have should I say